Hey guys, what's up? All set for a new program? Okay, let's move. We are gonna see the prime factorization of a number. You are required to display the prime factorization of a number, take as input a number n, and print all its prime factors from smallest to largest. Okay, say for example, if the number is 14440, the prime factors would be 2, 2, 2, 2, 2, 3, 3, 5. How this comes? Let's see. Say my number is 56. So how do we calculate the prime factors? We divide the number by prime numbers. So first I'll start with 2. It gives me 28. Again I'll divide it with 2. It gives me 14. Again I divide it with 2. It gives me 7. Now 7 by 2 won't happen, right? Because it would give us decimal numbers, which is not acceptable. Okay. So I will now check for the next factor, next prime factor, which is 3. 3 won't divide. Next, I will check for 5. 5 won't divide. Next, I will check for 7. Yes, 7 will divide it, and so 7 by 7 will give me 1, 0 as a quotient, and 1 as a quotient, and nothing. So my prime factors would be this 2, then this 2, then this 2, and then this 7. How? 2, 2, 2, and 7 for 56. Okay. Let me take another example, say 46. Now we are dividing 46 by the smallest prime number, which is 2. Check if it divides. Yes, it will divide. It will give me 23. Now 23 divided by 2 won't give me any number. So I will check because it will give me a remainder, and all these prime numbers should divide them and give them a 0 as remainder. To continue, that is why here we didn't divide 7 by 2 because it was giving us one remainder. So that won't suffice for us. So we did it checked with 3, 5, and then 7, and finally got that 7 was being divided by 7 to give us remainder 0. So we checked it at that point and we kept it there. So 2, 2, 2, and 7 are prime factors for this 56. Here 46 by 2 gives me 23. Now I'll check that 23 is not divided by 2, not even by 3, not even by 5, not even by 7, not even by 11, and so on. But it divides by 23. 23 divided by 23 gives me 1 as quotient and 0 as remainder. So for 46, my prime factors would be 2 and, yes, you guessed it right, 23. Okay. Now, how come this came? We have done the prime factor, counting the prime numbers, taking out prime numbers program. We'll utilize the same logic. Let's see how do we do it. We need to take input, so we are using the scanner scn command. Scanner scn equals new scanner system.in. Take input as n, so n would be input number, input variable, and then this would come here. And now, one more thing I would like to remind you, this prime factorization calculator is a classic example of nested looping. See how. I will utilize my favorite loop, for loop, and also the while loop. Let's see why and how. I'm taking a divisor since it will be my prime numbers, and it will start from 2 because 1 divides every number. So 2, and then I need to go till n and with the increase of 1. So I get it here, and then while n mod div equals 0, till that only. Here it was dividing and giving me remainder as 0, so I continued with it. When I am not getting the remainder as 0, when I divide 7 by 2, I will come out of the loop. And then again I will go in this for loop. So here, while n mod div equals 0, I need to perform this check where I will do n is equal to n by div, and then I will print system.out.print my factors, which will be div and C. The output format should be spaces. So I won't be utilizing the println command because println gives me a new line. The output would come vertically 2, 2, 2, 2, 2. But I need to print those in the same line, so I would be using only print command, and for the spacing I can do this. Okay, so this is done. Now it will check for 2, it will check for 3, it will check for 4, it will check for 5, it will check for 7. It will go till n. But you remember we optimized this code wherein, say, suppose a number p and q were p and q gave me n, so p would not be greater than n root n. P can't be greater than root n, so square root of n can't be, and q also can't be greater than square root of n, so it is always less than square root of n. This one is also always less than square root of n. So I can optimize this by making my divisor go till square root of n. Okay, but then you'll say, what about the 7? Because 14 by 2 gave me 7, and the square root of 7 is somewhere near about, say, 2 point something. So the 7 would be left out. In this case, this 23 would be left out because 23's square root is 4 point something. So I won't be checking afterwards. So this 23 won't come. Oh, that's a big problem. So what do? We can do one more thing. See what? This remaining number, if it is not equals to 1, because the last 7 by 7 was giving me 1 as quotient. So if it is not 1, then that is the only number which is greater than root n and can divide this n. It is the only number. There can be no number greater than root n individually to divide that number, except only this number, which is not equal to 1 in the last number. So if n mod not equals 1, I will print this also. System.out.print, I'll print n. Okay, like we saw it here, this 23 was the only number, and there was no other number between 2 and 23 which was dividing 46, and there can't be any number greater than 23 also which will divide this. Here also for 7 there wasn't any number which was dividing except for 7 itself. Okay, so we get this. We will have only one number greater than the square root of n which will divide it and will be the prime factor of that number. So let's see and run this program and see if it works. Let me run it, and Okay, this will give me errors because these are not commented. So I'm commenting it and it will run. And since my input was 1440, by default it is giving me 222222335. Let me change the input as, say we are taking 56, so I'll take 56. The output would be 2 and 7. Yes, you get it right. If it is 46, the output should come as 2 and 23. Let us check for 2 and 23. Yes. And if the number is, say, 450, what will be the output? Let's check. The factors would be 2, 3, 3, and 25. Okay. So yes, that's good. Thank you for watching. Bye. And before that, wait. Let me check it for all cases. I'll submit it. Check it. If it comes out, and let me see if it works. Yes, it passes all test cases as I get 10 out of 10. So thank you for watching. Bye.